In this video, we're going to be talking about the first 3 of 5 reaction patterns: synthesis, decomposition, and combustion. The other 2 types of reaction pattern are called single replacement and double replacement. We'll take care of those in the next video. The idea is we're going to go over what the pattern is, what the pattern looks like, how it works, and how to predict the products of the reaction using that pattern. Again, you will need something to write with, you'll need something to write on, and once you have those, let's go. Okay, first type of reaction is synthesis. If you think about what synthesis means in general, it means putting things together. That's what a synthesis reaction is. We take 2 smaller reactants, combine them together into one larger product. Usually the way you're going to see this is you're going to see 2 individual elements as your reactants, and they're going to combine to form a compound. To make the formula of the compound, you just drop and swap the charges. Okay, so here's an example that we have: aluminum plus bromine. 2 elements will combine to form a compound, so we're going to have aluminum and bromine in a compound. We have to drop and swap. Aluminum has a +3 charge. Bromide has a -1 charge. Drop and swap them, we get AlBr3. Please note, subscripts do not carry across the arrow unless they're part of a group on your chart of charges. That's the only time they'll move across. Otherwise, whenever you're predicting products, you drop and swap from new. Right, so we have Al plus Br2 yields AlBr3. The last step of this process is we have to balance. 1 aluminum on the left, 1 on the right. That's good. 2 bromines on the left, 3 on the right. Those don't balance. So what I have to do is I have to use least common multiple. What's the smallest number that 2 and 3 can both divide into? Answer, 6. So I'm going to make the bromines equal 6 on both sides. To do that, I'm going to do 3 Br2 and 2 AlBr3. Now our bromines are balanced at 6 apiece. But you notice, putting that 2 in front of the aluminum bromide brought our aluminum out of balance. So now I'm just going to go back to the other side, put the 2 in there, and now our equation is balanced and we're done. So 2Al plus 3Br2 yields 2AlBr3. That is our synthesis reaction for the combination of aluminum and bromine. All other synthesis reactions will work similarly to this. Our second type is decomposition. So if synthesis is the bringing together of multiple things, decomposition is when things break down, right? So a decomposition reaction is when you have one substance and it breaks up into other smaller substances. Those can be elements or smaller compounds. And based on what it is depending on the type of decomposition. So what we have right here is an example of a basic decomposition or a binary decomposition, right? Because it's 2 elements, sodium and oxygen. Whenever you have a compound that's composed of 2 elements and it decomposes, it will break up into its 2 elements. What that means is that sodium oxide will break up into Na and oxygen, which the formula for oxygen is O2, because remember, oxygen is diatomic. Right, so when oxygen is by itself, it has to be O2. Now we look at our equation, it's not at all balanced. I have 2 NAs on the left. I need 2 on the right, so I'm going to put in a coefficient 2. I have 1 O on the left, 2 O's on the right, so I need to change my coefficient for the sodium oxide to a 2. But doing that changes the sodium. I went from 2 to 4. So I changed the coefficient on the other side to be 4Na. So our final balanced equation is 2Na2O yields 4Na plus O2. So that is a binary decomposition. Compound breaks up into its individual elements. Just remember your diatomics. Now there are 3 other patterns of decomposition that I want you to know. The first one is called a carbonate. So if you have a metallic carbonate, so the example here is sodium carbonate, Na2CO3. If you decompose a metallic carbonate, you'll get the metal oxide, so Na2O is sodium oxide, and carbon dioxide gas, CO2. Our equation for this one is already balanced. So that's decomposition of a carbonate. It forms the oxide and CO2 gas. For a chlorate decomposes into the chloride and oxygen gas. Okay, so sodium chlorate, NaClO3, breaks up into sodium chloride plus O2 because that's oxygen, and then we balance the equation. And our final type of decomposition is what's called a hydroxide, right? So metallic hydroxides, NaOH in this case, breaks up into the metal oxide, or in this case sodium oxide, Na2O, and water, H2O. So those are the three special types of decomposition that you should know, because I'm going to throw those at you quite a bit. So 4 different types of decomposition reaction you have to be aware of and be able to predict products for. And again, the only difference in these reactions is what the formulas will exactly look like based on your drop and swap, but they all follow the same general patterns. The last pattern we're going to talk about in this video is combustion, and combustion is by far the easiest one. Combustion is when you burn a hydrocarbon in air or oxygen. Hydrocarbon, by the definition of the word, contains hydrogen and carbon. Now, hydrocarbons can also have other elements, like, for example, oxygen is a very common one. Sometimes you'll see sulfur or nitrogen. We'll go through how to do like sulfur and nitrogen compounds when we come across those in class, but for right now, it's usually just C and H or C, H, and O. The nice thing about combustion reactions is they always produce the same 2 products. No matter what hydrocarbon you're burning, you're always going to make carbon dioxide and water. Okay, so those are always your 2 products no matter what, and then you balance the equation. So for our reaction here, we have butane, C4H10, lighter fluid, burning in oxygen. Now, because it's combustion, the 2 products are CO2 and H2O. Take a minute to try to balance this for me, though. All right, so pause the video, balance the equation, and come back when you either have the answer or you've given up trying to find it. Okay, so this one right here is kind of a little bit difficult because you're going to have to keep going back and forth. There are 2 ways that you can work through this. The way that I would prefer to work through this is to start off with a fraction and then multiply up if I need to. Okay, so I have 4 carbons on the left. That means I need 4 CO2s. 10 hydrogens on the left means to get 10 on the right, I have to take my H2, multiply it by 5. That gives me 4 times 2, which is 8, plus 5 oxygens on the right, so 13 oxygens. Now I need 13 oxygens on the left. The problem is O2 means I'm going to have an even number no matter what I do. So the way that I'm going to work through this, the easiest way I think, is what times 2 gives me 13? 13 halves. Right, so I'm going to have 13 halves O2. Can we have a fraction in our equation? Not right now, we can't. Maybe later in the year I might let you use fractions, but not right now. For right now, you have to use integers. So just like our empirical formula problem, how do I get rid of a half? We get rid of a half by doubling it. And then what you do to one thing, you do to the other. So I'm going to take that, I'm going to double all of my coefficients, and I'm going to wind up with 2 C4H10 plus 13 O2 yields 8 CO2 plus 10 H2O. And that's balanced and in lowest ratio. The other way that you can go about doing this if you have just carbon and hydrogen is look at the number of hydrogens in your formula. If it's divisible by 4, then the coefficient for your hydrocarbon is going to be 1, balance is normal, it will work out. If the coefficient for your hydrogen is not divisible by 4, but it is divisible by 2, then put a 2 coefficient in front of your hydrocarbon and balance it out as normal. If it's neither, then you have to try to work through it, and best of luck to you. Again, one of the things to keep in mind with balancing is that there's always going to be some amount of guess and check until you kind of work out whatever you think the right answer is. So those are our first 3 patterns: synthesis, decomposition, combustion. Next video, we're going to cover replacement reactions.